Welcome to you all official matriculants. This is your favorite show, Learn Extra Live, with me, AB. It is also on a Triple M day, which is Mindset's Maths Monday. I'm joined by Temlin again.
Hi, I'm well. How are you?
I'm also well. Even
Good.
this week, I'm super charged.
You feeling good?
I'm feeling good.
Awesome.
Well, I had a busy weekend, but it was all good because it
that's
was
good.
with the Mindsetters.
Oh, awesome. Well, there you go.
Yeah.
Energizes you.
Yeah. And what are we doing today?
Today we're going to be carrying on with triangles. So I know by the end of today, all the grade 11s and 12s will be well equipped to deal with all the triangles they're going to be facing. But today we're going to be focusing a little bit more on the three-dimensional triangles. Last week we did quite a lot of work on two-dimensional. So today we're going to kind of bring it more into the grade 12 level of things.
I like that one. Thank you. Now, Mindsetters, what you need to do is to join us on Facebook, like our page, tell your friends about our page. Our page is facebook.com/Learn Extra. It is XTRA without any E. And also on the page, we'll be posting some questions. We will also get an opportunity to help other Mindsetters because we are a team. Otherwise, you can also tweet us at Learn Extra. Follow us also. Otherwise, you can also download your notes all for free on learnextra.co.za/live. That's how we do it, and now it's time to learn.
Thank you so much. Right, guys, as we mentioned last week, we had a look at our two-dimensional triangles where we applied the area rule, the sine rule, and the cos rule, okay? And we learned a couple of rules as to when to apply those three different rules. And what we're going to do today now is take everything we learned last week and apply it to three-dimensional triangles, okay? So let's have a very quick look at what we are doing in terms of our lesson description. Okay, again, we're having a quick look at our sine, our cosine, and our area rules, and this time we're going to be applying it to those three-dimensional triangles. Once we've actually done that, something else we're going to be incorporating into these triangles is your double and your compound angle formulas, okay? Grade 12, what you've learned in trig this year is those double and compound angle formulas. What's important to know is that they don't always get applied or only get applied to trig equations and reduction formula and identities, but they can actually also find their way into these 2D and 3D triangles. So we're going to just introduce that to you so that you know to look out for it if you have it in your paper. All right, then in terms of our key concepts, let's just quickly have a look at what we need to know for here. Right, quickly revising from last week, your area rule, just remember your area rule being your half multiplied by the two adjacent sides of an angle and its two adjacent sides. Okay, so it's always got to be an included angle when we are using our area rule. Sine rule, all right, remember for your sine rule, here is what it looks like. We take A over sine A, which is equal to B over sine B, or C over sine C. Remember, guys, what we spoke about last week is when do we know to use that sine rule, okay? Remember, essentially what we are looking for is a pair of a known angle and its opposite side. If ever you have that pair, grade 12s, that's when you know that you can apply your sine rule, all right? If you don't have a pair, that is when we are then going to look at applying your cos rule, okay? So a pair of an opposite side, an angle and its opposite side, sine rule. No pair of angle or opposite side, and then you're going to be looking at your cos rule. Your cos rule, we take the side squared, which is equal to b squared plus c squared, equal minus 2bc cos A. So if I had angle A and I had side B and side C, that would then be applying to that formula over there. All right. All right, and then very quickly, just to speak about your double and your compound angle formulas. Remember your compound angle formulas. If you're sitting with a cos of A plus B, remember your formula then is you're taking your cos A cos B minus, remember your cos rule, the sign always changes from what it was inside the brackets, and then sine A sine B, all right? Over here we had a minus, and we can see that it changed to plus. So please remember for your cos compound angle, your sign changes. For the sine compound angle, we've got sine of A plus B, therefore it becomes sine A cos B, plus, okay, so notice that this time the signs have stayed the same, and then cos A sine B. So a very small little trick that I tell everybody to try and help you remember, think of C for the cos compound angle identity, and think of C for change the sign. S for the sine compound angle formula, and S4 stays the same. All right. So compound, the sign change. Sorry, for cos, the compound formula, the sign changes, and for sine, it stays the same. And very quickly, finally, we've got our double angles. Okay, so just to remind you, we've got the sine double angle, which is 2 sine A cos A. And please remember that for a cos double angle, you've got 3 possible options. Okay, remember, we have all 3 available to us. We have to decide which would be the most convenient, the most useful one to use in the particular sum that we have. Okay. Right, okay, so that's a quick run through of everything that we need to know in terms of applying all of this information. Now let's put all of that theory into practice. Okay, so let's take a careful read through the first question and let's see what we're going to do with it. All right, we've got point A, B, and C, which are 3 points on the same horizontal plane, and AB is 53 meters in length. So let's quickly look at that. A, B, and C. So point A, B, and C are 3 points on the same horizontal plane. That is telling us that that is actually a flat surface, okay? That those 3 points are all just the same points on a flat surface, okay? And then they've told me that I have the length of AB, which is 53 centimeters. Okay, so that's given to us over there. Right, what else have they told me? Oh, sorry, it's meters. CD is a vertical tower, and the angle of elevation of D from A is 65 degrees. So the angle of elevation of D from A. Now remember, this is a flat line. That's a flat surface over there. So the angle from the flat surface looking up to angle D is 65 degrees. Okay, so that's your angle of elevation. From the flat horizontal viewpoint, we're looking up to the point at which they're specifying over there. Okay? And anything else have they told us? Let's see. And then we've got angle DAB, which is 78, and DBA, which is 56, which has actually been filled in on the diagram for us. Right, okay. So step number 1, when you are doing a question like this, you are going to read it very carefully, okay? Don't take for granted anything that's been told in your write-up. You need to read it all carefully and make sure that you just put everything in place, that you know what's going on with your question. Then we go on to read what they're actually asking of us. Determine the size of ADB. Where's ADB? ADB is looking for that whole angle over there. Okay, so before we do anything, before we dive into it, let's take a very careful look. Let's look through all the information that we've got. Let's see if we can determine without too much working out what is the size of angle ADB. Well, let's consider the triangle ADB, the big triangle at the front surface of that three-dimensional triangle over here. We know that that whole angle is 78 degrees, and we know that this whole angle is 56 degrees. So wouldn't angle D then be the third angle in that triangle? Okay, yes it would. So therefore what we're going to say is angle ADB is equal to 180 minus the two angles that we have, which are 78 and 56. Okay, and let's work that out quickly. Right, so we've got 180 minus my 78 plus my 56, and that gets us to 46. So there we go. That's the size of that angle over there, 46 degrees. Okay, right, so that was an easy one. Please don't forget that we do require reasons, okay? So the reason that we had, the reason why we gave that is because it was the interior angles of a triangle. All right, the interior angles of a triangle always add up to 180 degrees. Right, now that we know that that's 46, let's see what the next thing is that they are asking of us. Okay, I'm just going to fill in again that we know that that's 46 because I'm sure it's going to come in handy. Right, now they want from us the length from A to D. So let's highlight it quickly so we know what we're looking for. So that's what we're trying to find over there. Okay, so now we've got to go about looking for the length of AD, and the best suggestion would be let's start filling in what we know, okay? Let's start, sorry, that was 53 meters. So over here is 53 meters, okay. Right, guys, so I have got I've got the big triangle ADB that I had, which they've kind of directed my attention to by actually asking you to find the angle over here already. So we're kind of focusing on that first triangle as it stands at the moment. And because of that, I can see that I've got a pair of an angle and a side, and they're opposite each other, okay? So that's the known pair that you're looking for, and that's what's going to help you find the length from A to D, because I know that this whole angle over here is 56, which means that there's the other pair that we're looking for, okay? So, therefore, what are we going to say? I'm going to take the length of 53, and I'm going to put it over sine of the angle opposite that, which is 46 degrees, okay? And then I say my length from A to D, which is what I'd need to find, over sine of the angle opposite that, which is 56 degrees, okay? With that then said, I'm going to say 53 multiplied by sine 56 over sine of 46, and that's equal to AD. Right, so what we used was the sine rule. How did I know to use the sine rule? Because I had a pair, an opposite pair of a known angle and a known side. Okay. Right, guys, and then we're going to take out our calculators again, and we're going to work this out. So we've got 53 multiplied by sine of 56 over sine of 46, and we get 61.08. So 61.08 meters is the length from A to D. 61.08. Okay, so that's what we've got so far. Hope you guys are understanding that. Okay, let's have a look at the next question. Now that we know, okay, let's just quickly go back. So we knew that that was 46 and 61.08. Okay. Now what they're asking us for is the length of the tower, or the height of the tower CD. So now we're looking for that over there. Okay, so we've now had to find the length from A to D, which essentially should be drawing our attention now into that triangle over there. All right? And let's assess the information that we have in that triangle. I know that this is 90 degrees over there. So that's a known angle of 90 degrees. And I now know the length opposite it, because that's what they asked me to do in the previous question, okay? So once again, can we all see that I've got that pair of an angle and a side? So in that case, because I know that this is 65, I'm once again going to be able to use that sine rule to find that vertical length from C to D. So therefore, we're going to say 61.08 over sine of 90, and if you all know your special angles, we'll know that sine of 90 is actually equal to 1, okay? And it's equal to the length we're looking for, which is CD, over sine of the angle opposite CD, which is 65 degrees. Okay, so therefore I'm going to take 61.08 multiplied by sine of 65. And guys, I'm not going to put it over sine of 90 because I know that sine of 90 is actually equal to 1. So it's not necessary to put it over 1. And then we can type that into the calculator. Right. Okay. So we've got 61.08 multiplied by sine of 65 degrees. And 55.3, let's round it up to 36. 55.36 is the length from C to D. Okay, right, so there we go. That was all the sine rule. There was no need for us to use the cos rule for that question over there. Let's have a quick look. We might have to break halfway, but let's have a quick look at this question. Let's get started with it and let's see how we go. All right, so now we've got a diagram and they're telling us that D is a point vertically above C. Right, so I've got a 90-degree height above there, vertically above. DC is y meters. Okay, so here's my y meters. In length, the angle of elevation of D from B. So once again, there's my horizontal viewpoint, and the angle of elevation of, sorry, let's actually erase, sorry, that line shouldn't be there. It should be there. Okay, the angle of elevation should be theta. Okay, looking up to D over there. and angle DAB. So DAB, the whole angle over here is alpha, and DBA, the whole angle over here is beta. Okay, so we've filled in all of that, we've taken note of it, now we need to start with our whole process. Guys, when a question is like this, my first suggestion is going to be this. Step number 1, read your question carefully. Okay, so we've done that, we've read through everything, and we've taken note of where everything is. Step number 2, try and fill in as much missing information on that diagram as you possibly can, okay? So before you even start trying to find any missing sides or angles or applying any sine or cos rule, find missing angles. So an example would be something like this. If that's alpha and that's beta, this angle over here is 180 minus alpha plus beta. And we know that because it's the interior angles of a triangle, all right? What else do we know? This angle over here is 90 degrees, and this little angle over there is theta, which means that in the triangle D, we don't have actually a point there, but this angle up here is going to then be 90 minus theta. And reason being, once again, it's the interior angles of a triangle. Right, let's take a careful look. Let's look at triangle DB, this angle over here. Let's give it a name. Let's call it P so we can call it something. All right, that is there. Do I have any missing angles or sides that I can find? I think you'll see that in this triangle. No, I don't. Okay. Right, so I have found as much as I can find at this point. All right, so what we're going to do, guys, is we're going to take a very short break, and when we come back, I'll continue with this question. But in the meantime, have a look at it, see if you can start piecing it together.
Thank you so much, Tamlin. Now, on Saturday, I happened to be at an expo, and here's a big shout out to the best group I met on Saturday, Group K, and especially to Princess Andy, who's watching the show from Ikangala Comprehensive School. A big shout out to you and to all the other mindsetters. Don't move, we'll see you after the break. Welcome back, Mindsetters. Now, here's a great note from Keleto. Keleto says, Tamlin, you better listen to this one carefully. So, Keleto says, it's official. We are dating. Grade 12, Len Extra, and I. And I'm and I'm all faithful about, and I'm all about being faithful. And now let's pass prelims, watch your steps, the world, watch your back, to all the matriculants of 2013. Isn't that sweet?
That's extremely sweet.
They're dating with Len Extra Live and grade 12.
Does that mean that we're all here to chaperone and keep an eye on things here?
And let's keep it faithful. All right.
All right, well, let's keep going with this one over here. Okay, so we finished off before the break by just finding missing angles, which I suggest is a very good way of starting questions like this. Okay, now that we've done that, let's see what they actually want of us. They want us to determine the length from D to B, and they want us to do it in terms of y and theta. You'll obviously notice in this question there are now no numbers, okay? Everything is just in terms of symbols, but that's fine. We're just going to apply the rule as we know, all right? Let's have a look. I'm trying to find the length from D to B. The first thing you're going to ask yourself is, do I have a pair of a known angle and its opposite side? Well, because you found this angle over here, that was what we did earlier. That then resulted in the fact, yes, we do have a pair of an angle and its opposite side, okay? So that means that we are going to be able to, sorry, I've actually highlighted the wrong thing. Let's just quickly erase. Sorry guys, one seckie. Let's take that out. It's the angle, this angle and its opposite side. There's my known pair over there. Okay. And all right, and what we're trying to find is dB, so that's the opposite, that's what we're looking for over there. Okay, so that's the known stuff. So dB is over sine of what? The angle opposite dB was 90, so sine of 90. And that's equal to the length of DC, which they told me earlier was a little y, and that's over sine of the angle opposite it, which is theta. Okay, so we're trying to find the length of dB, and they did state in terms of a y and a theta, which means that I've got y. Sine of 90, remember, is a value of 1, all right? So if I multiply it by 1, y is going to just stay y, and it's over sine theta. So that's the length from D to B right now. The length is y over sine theta. Okay, so now that we know that, let's see what the next thing is that they want us to calculate. Let's just fill that in. Y over sine theta is now what we know the length from D to B is. Right, now they're asking us to show that the length from A to B, so my length from A to B, is given as this. All right, so this is a proving question. They are not, under any circumstances, saying use that in your proof, okay? They are simply saying make sure that your answer eventually looks like the equation that they have given you, all right? So please don't make the mistake, grade 12s, of using that, all right? That's just there to guide your answer. All right, so I now have to try and find my length from A to B, and I need it to look like that. Okay, so let's just quickly fill in what we found earlier, just in case it's going to help us. So we knew that that was 180 minus alpha plus beta. Okay, well, let's see. We've now found this length from D to B, and they're trying to get me to find the length from A to B, all right? So what does that help me? What do we have over here? There's actually one more angle that I can find. Let's make it a different color. I know that that whole angle over there is alpha, and I know that this whole angle over here is beta. So therefore, do you agree with me that this whole angle over there is 180 minus alpha plus beta? That's the whole angle over there. In fact, I'm going to erase something over here. That is actually not alpha minus beta, and I'll tell you why. Because remember, beta is in fact the whole blue angle. That's why that actually would have been wrong. So we're not going to say that's not alpha minus beta. This one over here is. Okay. So that means that I've got a big angle, and I'm looking for its opposite side. And I've got an angle, and from the previous question, we actually found we know its opposite side. So there again, guys, we've got our sine rule, all right? So what are we going to do? We're going to take the length of DB, and we're going to put it over sine of angle A, that's the angle opposite it, and that's going to be equal to AB over sine of the big angle D, all right? So what have we got? DB is y over sine theta. And that's all over sine of angle A, which is alpha. That's equal to my length from A to B, which is what we're trying to find, over sine of angle D. And angle D, I'm going to have space here, is 180 minus, sorry, I'm going to write it underneath here, alpha plus beta. Okay, so what can we do with this now? Let's simplify. We have got y sine, just get back our pen. We've got y over sine theta. And instead of saying divided by sine alpha, what I'm actually going to say is times by, and instead of having a sine alpha over 1, I'm going to tip in times and write it as 1 over sine alpha. All right? Then I've got on this side, I've got AB over, and sine of 180 minus alpha plus beta. Do you guys recognize that that is actually a reduction formula? Okay. We're going to say 180 minus, which is in quadrant 2, and we know that sine is positive in quadrant 2. So we can actually reduce that to positive sine alpha plus beta. Okay. So I hope that that makes sense to you. Right, let's tidy up. I've got y over, that's going to be sine theta sine alpha. And I'm going to bring up the sine of alpha plus beta up onto the other side. Okay, and that's equal to AB. And does that give us what we were looking for? Let's just see. Oopsie. Okay, yep, that does. All right, so what were we looking for? We've got y multiplied by sine of alpha plus beta over sine theta times by sine alpha, and that's AB. All right, and let's double check ourselves. Does that all look like it should? Yes, it does. Okay, so I had no numbers. However, I used the sine rule just as I would if I did have the actual size of the angles, and I applied the rule exactly the same way. Only difference is that I had to accommodate the variables in certain ways, like using reduction formula, which often comes up, guys. So just remember that, and always remember to find missing angles before you even start to try and apply your sine or your cos rule, because that will definitely help you along the way. All right. Is there any other thing they want to know here? Right, no, we got a new question.
Here's a question for you before you move to that one, Tamlin. Mangoba Zondo says, would I be wrong if I use the Pythagoras theorem to solve for AB?
Let's go back 1 second and see. For AB. For the length of AB.
Yes.
Okay, yes, you would be wrong, and I'll tell you why. AB is part of two triangles in this diagram. It's part of the big triangle, ABD, all right? And it's part of the bottom triangle at the bottom here, that's a C, which is ABC, okay? Now, if you look at the big triangle, ABD, none of those angles are 90-degree angles, okay? And obviously, in order to use Pythagoras, you have to have a 90-degree triangle. And if you've got your bottom triangle, although those two angles, these two over here, are perpendicular, the one at the bottom, that angle there is not perpendicular, okay? So unfortunately, again, you have no 90-degree triangle, so you couldn't use Pythagoras to solve for AB in this case. You would actually have to use your sine rule there.
All right.
Okay.
Last one while you're still there from Shikash. Can't you just use the normal trig ratios to get DB?
To get DB, absolutely. Okay, you are absolutely right. Why? Because you have a 90-degree triangle. Okay, so this comes purely down to your preference. Okay, I like to use the sine rule. I think it's more habit than anything else. But can you use your sine ratios or sine, cos, or tan ratios here? Definitely, yes, you can, because you had that 90-degree angle. So I hope that answers your question. Okay. All right, guys, let's have another look at the next question. Okay. Okie dokes, we've got a figure which is representing angles A, B, and C, which are all in the same horizontal plane. So I hope by now you guys are understanding that that description is telling you that it's 3 points that are sitting on a flat surface. Okay. Point P is vertically above point A. Let's see if we can bring up the diagram just to tell you there. And B and C are 20 units apart. The angle of elevation from B to P, so from B to P is alpha, and angle ABC is theta, and finally we know that the angle ACB is beta. Okay, so we know all of that. We've read through it carefully. That's always step number 1. Step number 2, as I told you earlier, fill in as many missing angles as you can. Okay, it's just a safe starting point. So let's see what we can do over here. An example would be, I know that this is 90 degrees and I know that this is alpha. So do you guys see that this angle over here has got to be 90 minus alpha, because they are interior angles of a triangle, all right? If I know that this is theta and I've got beta over here, my angle in the middle is going to be 180 minus theta plus beta. Okay, so that's what we've got over there. I don't think I can find any other angles. I found as much as I can. Right, so that's step number 2 dealt with. All right, now that we've done that, the next thing you need to look for is, do you have a pair? All right, if we have a pair, we know we can apply the sine rule. If you don't have a pair, you know you're applying your cos rule. Okay. Let's see. They're asking us to prove that AP, so where's AP? Over here. They're asking us to prove that AP is equal to, and they've obviously once again given me the whole formula that they want me to prove. Okay. If I'm not mistaken, guys, please just change that to beta on your notes, because that actually was I need to just edit that there. Okay. Right, what have we got? By finding this angle over here, do you guys see that I have got a pair? All right? And I'm going to use that pair to help me find this side over here. So there is my sine rule to find the length from A to B. Why have I found the length from A to B? Because by finding AB, that will then bring me into the vertical triangle. So we actually have to start on the horizontal triangle to just find certain missing elements of the triangle, and then we move on to the vertical side. Okay, so we therefore are going to take the known side of 20, and I'm going to put it over sine of the angle opposite that, which is 180 minus theta plus beta. Okay, that is then going to be made equal to the length which I'm trying to find, which is my AB, and that is over sine of the angle opposite AB, which is beta. Okay, here, do we notice the reduction formula once again? So we've got 20 over sine of 180 minus is quadrant 2, which means it's going to be just theta plus beta, and it's equal to AB over sine beta. So finally what I'm going to do is bring that up to the top. So 20 sine beta over sine of theta plus beta is equal to AB. Okay? But, okay, let's just do a double check here. How close are we looking to what they wanted? I wanted a sine of a theta plus beta, so that's looking good. I wanted my 20 sine beta. Okay, so at the moment it looks like we're just missing the tan alpha part of this in order to actually finish it off. So let's see where we are. What we have just found is we've just found that length over there. But remember, what we're actually trying to find is the length from A to P. So this brings us now into this right-angled triangle. So to come back to the question that was asked earlier by one of the mind setters, could you just use the ratios of sine, cos, or tan here? Yes, you can, okay, because you've got a 90-degree triangle there. However, if your preference, if you see a sine rule and you would like to use that, you can do so, okay. I'm going to use the ratios because it's actually going to make life a bit easier here. We're trying to find from angle alpha, that over there is your opposite side, okay? And what we have just found is length AB, and that is your adjacent side. So the trig ratio that has opposite over adjacent is actually your tan ratio. So therefore we're going to say tan from angle alpha, sorry, this is all, from tan from angle alpha is equal to your length of PA. Your length of PA over the length that we've just found, which is 20 sine beta over sine of theta plus beta. Okay, so final step, we want to obviously get PA on its own, and what do we do instead of dividing? We multiply. So we say tan alpha multiplied by 20 sine beta over sine of theta plus beta, and that equals your PA. All right. I know we're close to a break, but may I quickly finish this question? Okay, I don't want to interrupt it in the middle. Okay. Quickly, last elements of this question. They now say to you, if AB is equal to AC, so they're saying that this length over here is equal to that length over there. All right? They want you to now write, based on obviously what you've just found, they want you to write the length of AP now as 10 tan alpha over cos beta. Right. So during this break, I want you guys to please think about that. Okay. Consider what are the properties of an isosceles triangle? What do we know about that? How can you convert what you've just found AP to be to now look like that? Good luck.
Shout your answers on the page and we'll see if you're right. But otherwise, as we're taking that break, I just want to send another big shout out to Ponzo Fortunate Malepe and Kakanyo Mulepo, who also I met on Saturday at the CR SWAT ICT Expo. Otherwise, Mindsetters, see you after the break. Welcome back, Matrix. Now on the page, Karoba Patrick says, nice chapter. It's simple like ABC. And also big shout out to Kaseba all the way from Zambia saying, I'm loving the show. To everybody that is in Zambia, hello. And let's continue.
Okay, so before the break, I wanted you to have a look at this. And this is kind of what I was hoping you were going to see. if I've got an isosceles triangle, one property of an isosceles triangle is that you've got equal angles opposite equal sides. Okay. Look at what they've got over here. They've got a tan alpha over cos beta. Do you see that, in fact, there's no theta there that we could work with? So, could I replace that theta with the beta? Well, yes, you can. Now, let's just set this out properly so that we set it out correctly. So, the first statement we're going to state is that theta is actually equal to beta. And the reason there is because we've got equal angles that are opposite equal sides. Okay? So therefore, what I'm going to then do is this. I'm going to go back for a second to my previous page. And let's take what we've just proven. So it was 20 sine beta tan alpha. In fact, let's do this so we can... No. 20 tan beta. I may have to come back. Tan beta, sine beta tan alpha. 20 tan beta sine alpha, and it was over sine of theta plus beta. Okay, over sine of theta plus beta. Okay, so that's what they've just asked me to prove in the previous question. That's what they wanted me to find AP to be, all right? And now they've thrown this little twist in the tail and said, no, well, hang on, actually, rather write AP as, and they've given it to us as 10 tan alpha over cos beta. So we've just stated that, in fact, theta and beta are equal to each other because it's an isosceles triangle. So therefore, what I'm going to do is I'm going to take the formula that I've just proven was equal to AP, except where I have got a theta, I'm going to replace it with a beta. Okay? And that is equal to AP. So if I tidy that up one more step, I'm going to say 20 tan beta sine alpha over, and you guys agree that what I've actually got here is sine of 2 beta. All right? We've got sine of 2 beta. So now let's talk about grade 12 trigonometry, in that over there is a double angle formula. All right? So let's apply that theory and say, well, if I've got a double angle formula for sine, it's going to look like this. I've got 20, I've got tan beta, and I've got sine alpha, and that is 2 sine beta cos beta. Okay? Well, then, what can we say from here? What can we say? We wanted it to equal tan cos. What can cancel? Am I not seeing something here? Give me 1 second, guys. Sorry, I just want to make sure I've got this right. Sine beta tan alpha. Did I have that right? Sine beta tan alpha. That's the problem. Okay. Sine beta and tan alpha. Okay, let's just fix that. Sine beta and tan alpha. Sorry, my color's not changed. All right, so the reason why that works is then because your sine betas cancel. 2 goes into 20 10 times, and I'm left with a 10 tan alpha over cos beta. Okay, and that's what we needed to prove. So that is an example of how we could actually incorporate our double angle identities into your 3D trigonometry. Okay, so Abram, I know a mindset asked earlier, when would they use the cos double angle? If I'm not mistaken, the question was asked as to, with a cos double angle, there are 3 possible identities, okay? And the mindsetter was asking, how do we know which one of the 3 to use? Okay, my answer to you is this. First of all, you need to do a lot of practice with them, okay? You need to go and do trig identities, and you need to really develop a very familiar idea of how these identities work, okay? Look at what you've got as your original equation, and look at what they're asking you to prove, all right? And my suggestion would be this. If you're trying to prove something that's got a combinations of sines and coses in it, then I would use the double angle identity that had a cos squared theta minus a sine squared theta. However, if you were trying to prove an identity that only had cos in it, then I would use the identity of 2 cos squared theta minus 1, because obviously that's just got cos. And the same with sine. If you're trying to prove something that just had sine in it, then use the one that's got your sine, just sine, okay? The good news is that it's not wrong or right, or it's not, well, let me say it's not wrong to use any of them, okay? It's simply which one is going to get you to the answer with the least amount of hassle, okay? So that's my suggestion. That's what you've got to go and do. But it does require a little bit of practice and just becoming familiar with it. So please don't shortchange yourself with that practice. You really do need to go and spend some time on that, okay? All right, so I hope that that helps you out there. Okay, guys, what else are we having to do over here? We're still on the same question. And what they often end up with a question like this is they say, once you've proven all of that, finally they're saying, well, if beta actually was the size of 55 degrees, and if alpha was 75 degrees, 55 and 75, then what I would do is that I would substitute them into the alpha and the beta, and I would actually get an answer on your calculator. Okay. Right, guys, so I'm going to let you go and actually complete that. It's just a case of substitution. There's nothing more to it than that. So just really go and sub it in and work that out for me. All right. Okay, let's have a look at an example, which hopefully is going to include a little bit of compound formulas. Okay. Once again, let's look at our diagram. They've given us a diagram that they've told us that TP is a vertical line. They've told us that PQR is in the same horizontal plane. And they've given us that that's angle Y. I've got a length of A. I've got an angle of X. And I've got an angle of 150. What they're wanting me to do is to prove that. They're wanting me to prove that my length from T to P is equal to A tan X multiplied by cos Y plus the root 3 sine Y. Okay. So let's go through our steps. Step number 1, you've read your question carefully. You've taken note of everything that they've told you. Step number 2, fill in any missing angles. Okay, so for example, if that's 150 and that's Y, this angle over here is going to be 180 minus my 150 plus my Y, because it's interior angles of a triangle, which means that angle R is going to be equal to 180 minus 150, which is actually 30, minus Y. And that's your interior angles of triangle. Okay, so that's what I know this is, and it's going to help me in a minute. You'll see in a second. Okay, so therefore, having filled in that missing angle over there, can we now, step number 3, spot any pairs? Well, let's see. I have now worked out that, well, I've got a 150 and I've got a side which is A. So that's great. I've got a known angle and its opposite side. And I'm going to use that to help me find the length from P to Q. Okay, PQ is the linking side between the two triangles. So that linking side is going to help you move into the top triangle, which is ultimately going to help you find your TP. Okay. All right, so let's go ahead and find that. We're going to do our sine rule. And let's work it out. So we're going to say my length of PQ over sine of 30 minus Y is equal to my length of A, that little A, over sine of 150. Okay, and let's simplify that. That means that I would have PQ, which is equal to A times by sine of 30 minus Y, and that's over sine of 150. Now, if we're familiar enough with trigonometry, we should always remember that your angle should never be bigger than 90, okay? So the second you do have it bigger than 90, we should immediately be applying your reduction formula. So 180 minus 30 is 150. So that means that PQ is going to be equal to A sine 30 minus Y over, and 180 minus is second quadrant where sine is positive, so it's sine 30. Okay, right, so as it stands, that's what we've got, all right, and that's the length from P to Q, all right. Now what we're going to do first of all, before we do anything more, is simplify this, okay. Do we spot that this over here is now a compound angle. Let's take out the D. It's not a double angle, it's a compound angle. Okay. And because it's a compound angle, what we're going to do is expand it. Okay. So let's do that. So we've got PQ, which is equal to A. Then I'm going to expand this. The sine compound angle does the following. We're going to say sine 30 cos y. And S for sine, S for stays the same. And then it's going to be cos 30 sine y. Okay, so grade 12, you recognize your compound angle formula there. And what we've got for now is over sine of 30. Okay. Let's now, I hope what you've now spotted is that I've got some special angles that I can work with over here. All right? I've got A multiplied by sine of 30 is the special angle of a half multiplied by cos y. And cos 30 is root 3 over 2 multiplied by sine y. And this is all over sine of 30, which in fact is going to be also a special angle. So let's take that out. It's a special angle of sine of 30, which is a half. Okay. Right, so far I hope you guys are following what we're doing over there. So I've expanded it as a compound angle. I've substituted or replaced my special angles. Now we just have to simplify. So let's see what we've got here. PQ is now equal to, do you guys agree with me that I could actually take out a common factor here? And that common factor is going to be a half. So I've got a half A, which inside my bracket is therefore going to leave me with a cos y minus a root 3 sine y. And this is all over a half. Okay, so I hope you guys are with me and you're following. And those cancel. So the distance from P to Q that we are now sitting with is an A multiplied by, cos y minus root 3 sine y. Let's do a check for a second. Let's go and see how close we are to what they want from us. They wanted us to have a tan x. Okay, we've got the A, we wanted that. We wanted a cos y, and we wanted a root 3 sine y. So do you guys agree? In fact, all we're missing over here is that tan, okay? But we're not done, all right? PQ, remember, was just the linking side between the two triangles. What we've done over here is we found PQ. What we need to work out is TP, okay? So we've got a 90-degree triangle. So let's work with our ratios of sine, cos, or tan. From your angle of x, what we're trying to find is your opposite side. And what we now know is the adjacent side. So your opposite of your adjacent is giving us our ratio of tan from angle x, which is equal to my opposite side, which is TP, over the adjacent side, which I worked out earlier, was A multiplied by cos y minus root 3 sine y. Okay, and one last step is obviously to multiply it up on the other side. So I'm going to say tan x multiplied by, because I'm multiplying, I can rearrange the order a little bit. So I'm going to put A in the front, and I'm going to put the bracket of cos y minus root 3 sine y. And that's TP. Okay, so there was quite a lot of working out there, and I completely agree it was a lot. But what I would suggest is that, first of all, you followed your steps, okay? You read your question, you found missing angles. Once you did that, you looked for a pair to see if you could apply your sine rule, okay? Once all of that was covered, really nothing more than applying your theory, okay? So you spotted that there was a double angle, or a compound angle in this case, and that there were special angles. So there were all of these elements that were kind of brought together in one sum, but if you just take it one step at a time, grade 12s, it is manageable. Okay, so don't get overwhelmed if it's a lot of working out, just take it one step at a time. Okay, right, so I hope that that was understood, and I would really suggest going back later and just go over it again and have a look, okay? Right, guys, I'm not sure if we're going to manage to get through all of this question, but I would like to get a start on it just to give you an idea. Okay. Let's have a quick look. We've got a telephone cable is to be erected between two cliff sides, and we've got these two sides over here, which is AD, and I've got EB. An engineer stands at point C. Okay, point C is down below over here, and that's where they are over there. And what they're saying is that he measures the angles of E from C and D to be theta and alpha respectively. So the angle of E from C. So E from C is that angle over there, all right? And they said that that would be theta. Then they said, now this is the part of the question that I think would catch many of you, so watch out for this over here. They said that angle E from D, okay, so the angle, he measures the angle of E from C and from D. So here's D, and he's looking up to E, all right? So do you guys agree we're going to have to construct a line over here? We're going to have to draw ourselves a line from D to E, all right? And just state that in your, when you're working out, construct line DE, okay? And they said that the angle from D to E was alpha. They said alpha here. The question is, where am I going from? Where is the baseline from which we're actually measuring that alpha? The question hasn't filled it in here, but you need to know that if you're ever looking at an angle of elevation, it's always got to be from a horizontal plane, which means that you're going to have to draw in your own line. I'm going to make it a dotted line over here. Okay, so we've constructed this line over here, which essentially means this, guys. We've created another triangle, okay? And that angle over, that angle over there was alpha. Right, so once all of that information is in place, the rest of it should be easy enough to do. You're going to follow your steps. You're going to find your missing angles. You are going to look for pairs to see if you can apply your sine rule. And I'll tell you, and if you can't use your sine rule, obviously your cos rule, otherwise use your trig ratios. So I would like you guys to see if you can go and finish that for me. The important part here that I really wanted you to understand, however, was that angle of elevation. So just watch out that if that horizontal line is not filled in for you, that you sometimes have to fill it in for yourself. So just be aware of that, okay? Guys, I hope that all helped you. I hope that when you are applying these questions that you all know what to do from here on out. And in fact, they're actually quite fun, so I hope you enjoy them.
All right, thank you so much. And a great compliment from Shikash says you should pass this to Tamlin. She has the neatest handwriting ever. So
thank you very much.
Right, keep it up also. And that's true, even my producer agrees. So I also agree, that's so true. Right, thank you very much. You don't write like a doctor. Thanks to all matrix for watching, and we just wish you all the best to all that are writing their trial exams. Otherwise, Mindset is always here for you. You know that nothing is ever impossible with a willing heart and a great spirit that is willing to learn. From us to you, we just want to say peace and have a good evening.
Bye-bye.